let me read the next question here. If delta G naught is nothing but here it is standard Gibbs free energy change. Standard Gibbs free energy change of the cell reaction. They have given a cell reaction here. That value is minus 21.52 kilojoules. And then for Gibbs free energy change for another reaction they have asked. The reaction remains to be same here because here silver chloride, that is 1 mole of silver chloride is undergoing for reduction reaction here, and here in this case the 2 moles of silver chloride is undergoing for reduction reaction here. Only the stoichiometric ratio is changing, that is 1 mole of AgCl and here it is 2 moles of AgCl. And they are asking us to calculate the what it is Gibbs free energy change. The formula to calculate the Gibbs free energy change is delta G naught is equal to minus N into F into E naught cell. Okay, this is the formula to calculate the Gibbs free energy change. But here the standard electrode potential of both the reactions, that is 1 and 2 reactions, remains to be same. Even though they have not given, but the standard electrode potentials of both the reactions remains to be same because this standard electrode potential does not depend on the stoichiometric ratio, that is here 1 mole of AgCl and here it is 2 moles of AgCl, because this electrode potential is an intensive property. The meaning of intensive property is that the properties that do not depend on the amount of substance and size of the substance. Intensive property. The example, one similar example I can give is density of water. So the density of water in a small glass of water is also same, as well as in a whole bucket full of water is also same, because the density is not dependent on the amount of the substance or size of the substance. Hence here electrode potentials of both the reactions is remaining to be the same here. So let me consider this first reaction delta G1. I'll take it as delta G1 and I'll take N1 here, and here it is E naught cell. This reaction as first one. I'll take another equation as delta G naught 2 minus N2 F into E naught cell. So let me divide this let me divide the equation 1 by 2, that is delta G naught 1 upon delta G naught 2. Okay, I'll take this one as 1 and this one as what it is here 2. Now it is minus N1F into E naught cell upon minus N2F into E naught cell. Instead of taking just N here, I have taken N1 and N2 because the number of electrons is changed in both the reactions. So delta G1 we already know the value, that is minus 21.52. Okay, minus 21.52. And delta G naught value remains to be same. Okay, I'll keep it as it is. And here for the first reaction, the number of electrons involved, that is 1 here. 1. And this F into E naught cell will get cancelled, and this the number of electrons involved in the second reaction is 2 here. 2 electrons are involved, so it is upon minus 2. This minus and minus becomes plus. So now let us calculate delta G naught. Delta G naught 2 is equal to, so this minus and minus becomes plus here. So it is minus 21.52 into 2. So the answer is minus 43.04 kilojoules is the answer for the Gibbs free energy change for the second reaction. It is going to change based on the stoichiometric ratio here. So the answer from the given question is option 3 is the answer.